Sure. Okay, so we need to find, for this kind of problem from Alex, the percent composition by mass for every element that's in that formula. So this is zinc bromate, and let's figure out how many of each element it has. So for zinc, according to the formula, it has 1 zinc per formula, right? There's no subscript 2, it's not in any parentheses, so the lack of any number there implies a 1. So there's just 1 zinc in the formula. And for bromine, inside of the parentheses, there's just 1 bromine inside of the parentheses, and there's 2 of them included. There's 2 bromates per formula unit here. So that's going to be 2 bromines for every formula equivalent. And then there's one more element, oxygen. And oxygen has a 3 for every bromate. There are 2 bromates, so I just multiply the subscript inside the parentheses times the subscript on the outside of the parentheses. So that's going to be 6 total. Now what I have to do is look up the atomic masses for each of these. So if I go to the periodic table, I look at oxygen, I find that it's 15.9994 or whatever. That's its atomic mass, its average weight, given all the isotopes that are abundant in the Earth's crust. And for bromine, I'm going to find the same kind of number, the atomic mass for bromine, which is 79.904. And for zinc, here's zinc, 65.38 grams per mole of zinc. So when I put all this together in Excel, okay, so what I'm going to do is multiply the count times the mass of each element. So here I have zinc, and here I have the atomic mass, and I multiply them together, and I get that 1 times 65.38 grams per mole is 65.38 grams per mole. And I can do the same thing here. So just the count times the atomic mass for that element as well, for bromine. Whoops. And I can just fill down and get a similar number for oxygen. So this number is just the product of 6 times 15.9994. And what I'm doing here is I'm trying to figure out what the mass contribution is for every kind of element. So yeah, I know that in the formula, 1 oxygen contributes 15.9994 atomic mass units on average, but what I want to know is what all 6 of them contribute, and that's what I get by multiplying 6 times the mass of each individual one. And I can actually come up with the sum. So this is the total. I could have written the molecular formula for that as well, like in this space here. I'm just going to add up all the products of the counts and the masses. So just add them up. And I get that number. So this is actually the formula mass for zinc bromate. So that's the total formula mass for zinc bromate. And you would calculate this if you needed to do any stoichiometry calculations with mass involved for this compound as well. And what I'm going to do is divide each of the mass contributions of every kind of element by that number. So I'm going to divide 65.38 by that. And that's the mass fraction that comes from zinc. So if I had a kilogram, or let's say 100 kilograms of, I'm converting it to a percentage. If I had 100 kilograms of zinc bromate, and I wanted to know how many kilograms of zinc were in that 100 kilograms of zinc bromate, it would be 20.36 kilograms. And I can fill down. They add up to 100%. Yay. So those are the percent contributions for each element to the total mass of zinc bromate. Round your answer to the nearest percentage. There might be actually a little bit of an issue with this one. So conceivably, you might run into a problem if you write down these rounded answers, because someone might get mad at you that they don't add up to 100%. Perhaps Alex might get mad at you or some program might get mad at you. So what I would do is I would actually calculate out the ones that are the smallest and then take the biggest contributor, I guess it's going to be this one that's 49.76%, and just subtract the other contributors from 100% and whoops, get the rounding the same. Great. So those would be my final answers, I guess. I guess I'd have to manually put this in as 49.75% to make this be the right rounded answer that adds up to 100%, but that's how I would do it. So that's how you define the mass percent from chemical formula. It's pretty easy. It's just a lot of calculations, and there's a lot of opportunity to make little mistakes. So you might want to double check your work. And if it's a multiple choice exam, make sure that your answer is basically spot on to the multiple choice answer.